Hi there, this is Mr. Roche. Welcome to another episode of Mr. Roche's Flip Class Math 10 No Frills, No Thrills, Low Budget, Low Tech videos. Today we're going to be investigating binomial products, multiplying two binomials, same thing, squaring binomials, and multiplying conjugate pairs. Before we start, I want to introduce you to my star pupil. This is Wilson. Wilson's really happy because he loves math. So I'm going to sit Wilson back here. He's going to help me with the camera work today. You good, Wilson? Yeah? Right on. Okay, here we go. First thing we're going to do is talk about multiplying two binomials or binomial products. Okay, when we multiply two binomials, first of all, it's going to look something like this. That's one binomial times another binomial. And remember, when we multiply things, it's like two factors or two dimensions. So I can use algebra tiles to illustrate what the answer would be. I'm going to move there now. Wilson, will you grab the camera, please? Okay, so here we have that same thing. Well, I have it the other way around, but that's okay. So x plus 2 is up this way, x plus 3 is this way. So if we fill all that in, here's what I'd get. You can see I'd have 1x squared, there it is. We'd have 3 x's, there they are right there. We'd have another 2 x's, there they are. And I'd have 6 1's, there they are. So we end up having 4 little sections, I guess you could call it. Notice we have 4 terms in this middle line. And of course, because 2 of these types of terms, the x's, are the same, we can combine those. Those are like terms, hence the 5x there. So generally speaking, when we multiply two binomials, it'll result in a trinomial. There are 2 exceptions, and we'll get to those later. Okay, let's go back to the board. Wilson, you got the camera? Thanks, Wilson. Okay, so when I do that, you'll notice I had the x by the x, which gave me the x squared. I also had an x by 2, or x times 2, or 2 groups of x, which gave me the 2 x's. I also had a group of 3 x's, which is this one times this one, plus 3 x's. And finally, we had 3 groups of 2, or 2 groups of 3 for my 6 individuals. And as you remember, we combined those like terms and got this product. Remember, that product is the area using the algebra tiles. Now, there is an acronym that will really help us use this, and it's called FOIL. It stands for the first term in each binomial. So first I multiply these two, then I multiply the outer terms or outside terms, they're the ones furthest apart, these two. Then I multiply the inner or inside terms, these two, they're the ones closest together in the middle, and then find the last term in each binomial, which is these two. If I do that, there's 4 separate multiplications, and I will get 4 terms. And remember, you're going to simplify the middle terms when possible. If you follow a different order, it'll still work, but the like terms might not be the innermost ones, like this. Okay? Let's try one more just so you can see it in action. I'll do a little bit more difficult one. I'll throw a minus sign in there as well. So, 2x plus 4 times 3x minus 5. Okay, so first the first terms. 2x times 3x is 6x squared. Then the outer terms. 2x times negative 5 is negative 10x's. Then the inner terms. 4 times 3x's is positive 12x's. And finally the last terms. 4 times negative 5 is negative 20. And like almost always, we can simplify those middle terms. So we have 6x squared, negative 10x's and positive 12x's is positive 2x's, and minus 20. And that's my simplified answer. I can't go any further. Of course, those are unlike terms, so I'm done. Okay, now we're going to go on to squaring a binomial. Squaring a binomial will look something like this. A binomial, here's a nice simple one. squared. And just like we have things like 5 squared equals 25, we can draw a picture of that. It would be 5 by 5. There's my 5 by 5, and my area is 25. And I'm going to do the same thing with my algebra tiles. Just get rid of that. Okay, Wilson, will you grab the camera again, please? Thanks. In fact, here's that same question, x plus 3 times x plus 3. So as you can see, the length and the width of the rectangle are the same, and the area, therefore, will end up being a square. In this case, we have x squared plus 3x's plus another 3x's plus 9. And of course, the 3x's would combine to give me 6x's. Notice the middle terms are the same, 3x and 3x. When we square a binomial, that will always happen. Therefore, instead of using FOIL, there is a shortcut. Let's go back to the board again, Wilson. Okay, as I was saying, there is a shortcut what we can do here. Instead of going, we could expand that out to being x plus 3 and x plus 3 and use FOIL. Or we could understand that the middle terms are going to be the same. So x plus 3 squared, well, that was redundant, wasn't it? I know that even if I use FOIL, I would have to go x times x, or x squared. There we go. The middle terms will always be the product of these two. So in this case, x times 3 is 3x. And the other one will be the same as that, another 3x. And the last one will be the 3 squared, which is 9. Now, rather than going through that process, because we understand that it will be the same, here's my shortcut, x squared. My two middle terms will be 3x and another 3x. So just multiply these two and then double that, because they'll be two the same. So 3 times x is 3x. If I double that, I get 6x. So plus 6x, or 6x's, and then square my last term, in this case is positive 3. And that's it. That's my answer. Okay, now my other possibility is, what if this were a minus? Okay, in this case, x squared. My middle term will be, sorry about that. My middle term will again be the product of these two doubled. So x times negative 3 is negative 3x, doubled is negative 6x. My last term, negative 3 squared, is negative 3 times negative 3 is positive 9. So you'll see when you square a binomial, you'll always get a positive and a positive for the ends, but the middle side of the middle term will always have the sign of this here. Okay? Or even of this one, if those ones were different. So this sign here depends, but these ones here will be positive. Okay. Let's go on to multiplying conjugate pairs. Conjugate pairs are two identical binomials except one pair of the signs will be different. So for example, x plus 3 times x minus 3. Okay? They're identical binomials, however there's one pair of different signs. And this would also work if these signs were the same and these ones were different. They'd still be regarded as conjugate pairs. Okay, let's go see the algebra tiles again and see what happens with those. Wilson, camera again please. Thanks, you're the best. Okay, here we have that same question, x plus 3 times x minus 3. So as you can see, there's the x minus 3, there's the x plus 3. So we have an x times x is a positive x squared. We also have here a negative 1, or all together negative 3, but each one of those negatives is lined up with a positive here, hence the negative x's. These ones, it's a positive lined up with a positive, so they're positive. And these ones would be these negative 3 combined with these positive 3 when we multiply, so there they are. Sorry about that light show there. Whoa. Okay, so what we have now is two terms in the middle that are opposite. And as you can see, they're going to cancel out. So we're going to get a binomial answer. Okay? Every time we multiply conjugate pairs, the middle terms will cancel out, leaving me with a binomial answer. That's the only time we'll multiply two binomials and get a binomial. If you try the shortcut with any other type of binomials, it'll result in a wrong solution. So don't do it unless it's conjugate pairs. All right, let's go back to the board. So I recognize these are conjugate pairs, okay? So I'm not even going to find the middle terms because they're going to cancel out anyways. So I'm simply going to multiply the first terms, x squared, and multiply the last terms, -9. Every time you multiply conjugates, you get a binomial. You'll always get a difference here or a subtraction, always. By the way, this is called a difference of perfect squares, or it's been simplified to just a difference of squares. Later on, we'll be recognizing those and factoring it back into these. But right now, we just need to do this process here. Let's try a more difficult one. 3x minus 7 times 3x plus 7. Okay, again, I recognize they're identical except for one pair of signs. I know the middle terms are going to cancel out if I use FOIL, so don't use FOIL. 3x times 3x is 9x squared. Positive, or -7 times +7, -49. And I'm done. Had there been a y in here, then it would be -49 y squared. All right? Okay, well, that's it. That brings me to the end of this particular part in this video series on polynomials. My next video, we will show yet some other polynomial type multiplications, including cubing a binomial, multiplying maybe a trinomial by a binomial, or trinomial times another trinomial, and so forth. And that will be my last set of videos in this particular unit. Okay, Mr. Roche here and Wilson saying goodbye for now.